Hey y'all, so before I get into how to multiply two digit by one digit numbers, I just want to go over some of the strategies that your child should already know before I explain how to actually solve this. That way you kind of have a little bit of background knowledge and you won't be confused on everything else that we're doing. So your child should have been exposed to these strategies prior to learning two digit by one digit multiplication. Okay, so the first one is an array. An array is just where they represent it by rows times columns or rows times how many in each row. So like for example, you see that it's 3 rows and it's 4 in each row or 4 columns. So 3 times 4 is 12. So this might be a problem like Johnny has 3 baskets. Each basket has 4 apples. How many apples are there in all? So you could do 3 rows to represent the baskets. You could do 4 X's in each row to show that they're apples and then go from there. Equal groups is basically the same, but instead you're doing circles and you're putting however many in each group. Repeated addition is also the same, but you're just adding repeatedly. So you have 3 baskets, so it's 3 4s. Because there's 4 apples in each basket. So you do 4 plus 4 plus 4. So it's basically 3 groups of 4. So they're all kind of the same. You're all basically, all of them, you're basically just adding 4 3 times. And then the number line. This time they kind of give you the numbers in a row so that you can actually count. So you'll go, okay, 4 8 12 on the number line, or if you need to, you can count up 4, count up 4 more, then count up 4 more. So you counted the first 4, you got to 4, you counted the next 4, you got to 8, and then the last set of 4, you got to 12. So these things are what your child should be exposed to prior to learning two digit by one digit multiplication. The top box, the array box, is what we're going to focus on mostly today, but I will show you some other little strategies that you could use as well. Okay, the next thing that your child definitely needs to know before we do what we're about to do is they need to know what their base 10 blocks look like. And as a parent, if you're trying to help your child, you also need to know what these base 10 blocks are. If you ever hear your child talk about a cube or a block, like a big, what's on the far left, that is worth 1,000. So if you ever see something on your child's homework that looks like that, that is just representing the number 1,000. A flat is a big square, a large square. Sometimes they have the little bitty squares inside them. When they're like a quick draw, they're just large boxes. Those are worth 100. And if you notice, or if you count it, that's 10 rows of 10. So it's actually 100 little squares inside. And actually, in order to make a thousands block, if you notice, or you noticed that it takes 10 of those to make 1,000, because 10 times 10 is 1,000. So this is kind of the concrete way of explaining that 100 times 10 is 1,000. Okay, so let's go to the rods. Each rod is worth 10. If you count, there's 10 squares. If you look at the flat, it takes 10 of those 10 rods to make a flat. And it proves 10 times 10 is 100. It would take 100 of those to make the thousands block. So you can kind of see that place value relationship. And I'm trying to do this quickly so I can get into the actual skill, but I hope y'all understand that. Then you have the unit, which is the ones. Sometimes you might see your child or your child's teacher draw it as a dot. That's just the quick way, or you may see them draw it as a little bitty square. But just know that 1 unit just means 1. 10 of those makes a 10. 100 of those makes a flat, and so on and so forth. Okay, so now let's dive into the multiplication. Okay, so we are going to go into doing two digit by one digit multiplication. I went ahead and picked out my problem, 23 times 7. The first skill that we're going to do is we're going to do repeated addition, which I showed you in the previous clips. Your child already knows how to do repeated addition, but they may not know how to do it with bigger numbers. I'm going to do two digit by one digit multiplication, but you can also apply these to the other, like maybe 3 digit by one digit, but this skill this strategy specifically may not be beneficial to do with those larger numbers, but I will show you other strategies that can also work with those larger numbers. Okay, so repeated addition. Basically, if you think about doing how I showed you equal groups, right? And in the equal groups, they had however many dots of however many in each set. Well, of course, I'm not going to sit here and draw 23 dots in 7 circles, because 23 in each, because that would take forever. So instead, I decided to make a strip diagram, and I'm just going to put 23 in each box. So that's 23 7 times. And most of the time you will see it like 7 times 23, because usually if it's 7 groups, however many groups would come first. But because of, I'm trying not to make this harder than it really is, because of the commutative property, it doesn't matter either way you flip it, you'll get the same answer. So that's why I'm doing it this way. Okay, so that just means I'm going to add 23 plus 23 plus 23 plus 23 plus 23 plus 23 plus 23. And I'm doing this one-handed, so bear with me. So 1, 2, 3, 4, 5, 6, 7. All right, so I have 7 23s. So this strategy is probably the one that's going to take the longest. But for your babies who just have no clue and cannot multiply, even if they try their hardest, or I would say struggle with multiplication, this should be the go-to. Hey, if I'm good with adding, but I'm struggling with this multiplication, until I get it, I'm gonna add my little tail off. Okay, so I know 23 plus 23 is 46. Okay, and I would recommend chunking it like that in groups of 2, and not trying to just make a row of 7 23s and just keep adding the 3s and adding the 2s. For an adult, that's easy. Maybe for a high school student, they can do that. But for a younger child, I wouldn't recommend that, because it lends itself to more errors than doing it this way. So now all I need to do is add 46 3 times. So I can do 40. All right, so I'm going to add 46 and 46 first, and then I'm going to add my next 46, and then I can't forget about my 23 there. All right, so when I add my 40, I think I left it. There we go. 46 plus 46. That will give me 92. I'm going to go over here, and I'm going to do 92 plus my third 46, 8, 138. And then I need to add my 138 to 23. I'm going to just do that down here. Now, if it's a younger child, I would encourage them to try to either stay on the same line for place value purposes, or I would at least have them stay in the same area. But since y'all are older, I think y'all got it. So right now my answer is 161. So all I did was add. This is repeated addition. So I got this answer from adding repeatedly. Okay, so now we're going to go to the next strategy and see if that works as well, and see if we get 161. Now I have equal groups on my paper. Miss Moody, you just said that equal groups would take too long. I'm not drawing 23 dots in 7 circles. That's going to take forever. You are correct. But what we can do is what I showed you at the beginning of the video. We can use our 10s and our 1s. And remember, our 10s were those little blocks that look like that, the rods, and our 1s were the little squares. A quicker way to draw that is to draw just a little stick for the 10s and just a little dot for the 1s. So I'm going to do sticks and dots because that's what I like to do. But if you prefer doing your rods like that, that's fine. So because I'm doing 23 times 7, I'm going to do my 7 groups, and I'm going to put 23 in each. Now, instead of drawing out 23 dots, again, I want to use my 10s and my 1s. If each stick is worth 10, then I'm going 10, 20, 1, 2, 3. 10, 20, 1, 2, 3. 10, 20, 1, 2, 3. 10, 20, 1, 2, 3. 10, 20, 1, 2, 3. 10, 20, 21, 22, 23. 10, 20, 21, 22, 23. All right, so those are 23, 7 groups and 23 in each. So now I can just count. And guess what? If I want to get fancy, I can count by 20s. So I can go 20, 40, 60, 80, 100, 120, 140, 141, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61. I got 161 again, and I did something totally different. All right, let's see what we got next. Okay, our next strategy is an array. We talked about that, how it's just rows times columns. But do I really want to sit there and draw 23 dots in each row in 7 rows? No, ma'am. No, sir. But I can connect it to what I just did with my equal groups, and I can do an array with 10s and 1s, right? So what I want to do is, instead of doing 7 rows with 23 dots, I'm going to do 7 rows with 2 10s and 3 dots in each row. Okay, now there's 2 ways you could do your array. I like to do my rods horizontally when I make arrays, but just so you can see it, I'm going to do it both ways. So if I wanted to do it vertically, I can do 23, 23, 7 times. 1, 2, 3, 4, 5, 6, and I'll put another one at the top. 7. Now, I don't like that because it doesn't make rows to me. Like it makes rows, but it just doesn't look right. So I do my 10 sideways. 10, 20, 1, 2, 3. 10, 20, 21, 22, 23. 10, 20, 21, 22, 23. 10, 20, 21, 22, 23. 10, 20, 21, 22, 23. 10, 20, 21, 22, 23. 1, 2, 3, 4, 5, 6, and then 7. Now, when you're doing this, you won't have to count, but I'm doing that, just for modeling purposes. You'll just do your 23 7 times. Now, I'm going to count my row. I'm going to count, and if you notice, I always count my 10s first. You don't want to have to do 23, then add on, then add on. So I always count my 10s first. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 10, 20, 30, 40. And then I'm going to do my ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to do groups of 10 just for my purposes, but you could just count it out if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I have one little dot left. So I have 100 plus 40, which is 140, 150, 160, 161. I think we're right. So this is how I do this. But like I said, you could have counted these all by 10s and just got to 140. And then you could have counted all your ones and you would have just had 21. Just like I have here, 2 10s and a 1, that's 21. So if I counted the dots individually, it'd be 21. And I could have added my 140 plus my 21. Guess what I get? 161. Okay, now we're getting to the easy stuff that won't take forever. But the reason why I went through the other strategies is because you have to realize that these kids don't know they're not at the level where they can just jump into doing an algorithm. So we have to transition them from concrete to pictorial to abstract. And so a lot of today's, actually all of the, most of what we've done so far is pictorial. I believe I said concrete earlier, but concrete is technically where they actually have blocks or manipulatives that they're moving around. Okay, so the open array. It's very similar to the array we just did, but this time we're going to use boxes and just numbers. We're done with pictures. We're too old for that. All right, So what I'm going to do is I'm going to break apart the number 23. So instead of saying 23, I'm just going to say 20 plus 3 times 7. And so I'm just going to multiply. 20 times 7 is 140. 7 times 3 is 21. 140 plus 21 is 161. And I want to show you the connection. Okay, so this is the array we just did. 20, because this row is 20, because there's 23 in each row. There's 20, I'm sorry, there's 2 tens, which is worth 20, and then there's 3 ones, so 23. And then there's 7 rows. 1, 2, 3, 4, 5, 6, 7. So that's how I got the 20 plus 3 times 7. If I count, when I counted all of these, 20 times 7, I got 140. When I did 3 times 7, if I have 7 rows and 3 in each, it's going to give me 21. So that's 161. So in order to understand this, your child had to see this. And so when they come home with this and you're wondering, what is this teacher doing? Why isn't she just doing the algorithm? It's because they're here and they're transitioning to here. Okay, so our next one is the distributive property. It's basically very similar to the open array, except you don't need a model this time. So if I have 23 times 7, I know that 23 is the same as 20 plus 3. So I'm going to do 20 plus 3 times 7. So that means I can do 20 times 7 plus 3 times 7. I'm just breaking it up into smaller chunks to make it easier for myself, because it's easier to multiply 20 times 7 and it's easier to multiply 3 times 7 than trying to multiply 23 times 7 in some students' eyes. So I know 2 times 7 is 14, so 20 times 7 is 140. 3 times 7 is 21. And I'm back to that 140 plus 21, which is 161. So many different strategies, but you're all getting the right answer. And that's what we're trying to get kids to. We're trying to get them to the state where you don't have to just do it one way. If this works better for you, do it. And it's still going to work. Your friend might draw it out. Your other friend might use a number line, but you may do this and it's going to work for all of you. So we're trying to get kids out of that stuck, oh, I have to do this. This is a different problem, but I just wanted to show you that the distributive property can go both ways. So I can do what I kind of just did. Like I can break something up and it doesn't have to just be tens and ones. Like I can do, well, I don't know 20 times 7, but I know what 10 times 7 is. And I know 10 times 10 is 20. So I can do 10 times 10, 10 plus 10 times 7. So I can do 10 times 7 plus 10 times 7. So I know that 70 plus 70, 70 plus 70 is 140, right? Or I could even do this, 20 times 7. Well, I don't know 20 times 7, but I know 20 times 5 is 100. And I know that 7 is 5 plus 2. So I could do 20, and I'm going to write it vertically, even though I don't recommend doing that, but just for spatial purposes, 20 times 5 and 20 times 2. So I have 100. Sorry, I'm trying to hold and work. I have 100. And I have 40. 100 plus 40. 140. So you can always do it both ways. All right, y'all. Here's the moment you all have been waiting for. Mama and Daddy's favorite, the algorithm. What you love to teach your kids, even though we tell you not to yet, and you do it anyway. Everything I've done in this long video so far has led us to this abstract concept. The algorithm. Your child needs that foundation that I just showed you before they can get to this. Yes, we teach them the algorithm. The algorithm is going to save their lives many of times, especially in middle school and high school. But they need that foundation that I just showed you. So don't just turn away those strategies we're sending home. I know it takes longer, but they have to be thinkers and they have to know why this works. So everything I just did will explain why this works. So, as you know, the first thing we do is we multiply the ones. 7 times 3 is 21. Okay? Well, I'm going to put my 1 in my ones place, because remember, this is just the tens place. This is the ones place. I'm going to put my 1 in my ones place, and then I'm going to add 2 more tens. Let me show you what that looks like. Remember this? I have 23 times 7, and I want to multiply my ones first. 7 times 3 is 21, right? I had that 1 left over, and I made these into 2 tens. So they're basically equal to one of these. So all it is like I'm moving these over here. That's what that plus 2 means. And I know as adults, some of us didn't really know that. We just did it because our teacher told us to do it. But guess what? Now you know. So I just moved those 2 tens over here. That's what that means. Just plus 2 more tens. So I have my 1 left over, my 1. And my tens are going now in the tens place. All right, then I do my tens. 7 times 2, which means 7 times 2 tens, which is 140, right? Same here. 7 times 20, which is 7 times 2 tens, correct? All right, so I get 140, which is what I got here, right? But then I had to add my 2 tens. So I got 140, but I have to add my 2 tens. So that's 140 plus 20, that's 160. Well, why didn't I put 160? Because this is the tens place. So 16 tens is 160. Watch. This was 14 tens. That was 140. Because see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 14 tens. That's 140. So I add 2 more tens, 150, 160. So, and also, so this is 14. That's 15 tens, 16 tens. I hope y'all get what I'm saying. But, and I hope I got a lot of ahas like, oh, wow. Oh, that's what that is. This is what we're teaching your kids. So we don't want them to just memorize this. We want them to understand why we're doing this. And look, we got 161. So just be patient. We want your kids, we don't want your kids to just memorize like we did. Yeah, they're going to get the right answer. But if they don't know how, when those tough problems come, or when they have to reason and it's something they don't know, or a number, they don't know the multiplication fact, they can break it apart and get those numbers using their brain and using their thinking. Because when you just memorize, you have no foundation on why. You just memorizing. So then when something looks different, you don't know what to do. And so I hope this helped y'all. Any teachers, I hope it helped y'all be able to explain, because just like parents learn this way, teachers learn this way. So imagine learning this way and then having to teach all of this. Having that foundation helps. Okay, so y'all enjoy y'all's night.